All right, so we're going to move on. We're going to talk about some more solving of trig functions. This one's going to involve your calculator. So this is still section 8.4, but this is day 2. And so what we're going to do is we're going to solve the following equation. We're going to solve 3 times cosine of x is equal to 2. And we want to solve it for x in the interval 0 degrees to 360 degrees. So the first thing we have to do is get cosine of x by itself. So we're going to divide both sides by 3, and we get cosine of x is equal to 2/3. And then to get x by itself, we talked about in the last video that x is going to be equal to the inverse cosine of 2/3. In other words, what angle x makes the cosine adjacent over hypotenuse come out to be 2/3 when we reduce it down. Problem is 2/3 is not a unit circle value. So what we're going to have to do is we're going to have to use our calculator to figure this out. So what we do is we grab our calculator. First thing you need to absolutely make sure of is you need to make absolute sure that you are set to the proper units, which in this case is degrees, which I am. So what I'm going to do is I'm going to punch in second function or shift and then cosine, parentheses, 2 divided by 3. I need to do parentheses because if I don't, it will do inverse cosine of 2 and then take that answer and try and divide by 3. I want it to take the inverse cosine of that value 2/3, so I need the parentheses. There we go. So we're going to round to the nearest tenth, so this is going to round off to 48.2 degrees. So this tells us that x is about equal to 48.2 degrees. The problem is that is not the only answer between 0 and 360. Let's stop and think about why that is. So when I draw my little quick picture, and again, you need to get in the habit of doing this. This really does help you visualize what's going on. Cosine is equal to 2/3 at about 48.2 degrees. So we have an angle here of about 48.2, which gives us a cosine and x coordinate of 2/3. The question is, where else is cosine going to be positive 2/3? And so you need to stop and think about our other quadrants. Is there another quadrant where cosine is positive? And the answer is, of course, yes. It's positive in quadrant 4. The question is, what angle is this? And to find it, we're going to go back to something that I talked about back in chapter 6, and that is the idea of reference angles. And I told you back in chapter 6 that we would learn about reference angles in chapter 6, but we wouldn't use them until chapter 8, and then they would become very important. We are now there. Here's the idea. We have to figure out how far in degrees, or in radians, in this case degrees, we are away from the closest spot on the x-axis. So are we going to go counterclockwise, or are we going to go clockwise is the question. Well, the one that's shorter is clockwise. So we're going to go clockwise to the x-axis, and from here to here, from 0 to 48.2 is 48.2 degrees. This is our reference angle. Remember, a reference angle is a quadrant 1 angle between 0 and 90 degrees, or between 0 and pi over 2, that gets you to the nearest place on the x-axis. Remember, always the x-axis, never the y-axis, because we're in standard position, and standard position starts the numbering system from the positive x-axis at 0. So this is our 0 degrees. So if I want to move into quadrant 4, what I now do is I now take that reference angle and I apply it here. So I have to go backwards. Now, I could subtract and make this negative 48.2 degrees. That would get me to the right place. The problem is it won't satisfy the instructions. Remember I told you in the last video, you've got to read the instructions. It says clearly between 0 degrees and 360 degrees, negative 48.2 does not satisfy that. So what we have to do is we have to find another way to get there. Instead of going this way, we're going to go around this way to get to that same place. And so what you do is, instead of thinking of this as 0 degrees, you think of it as 360 degrees. This reference angle is 48.2. So what do we do to get this answer? We do 360 minus 48.2 degrees, and that's going to give us 311.8 degrees, which is this answer. So our two answers are going to be 48.2 degrees and 311.8 degrees. So again, we use our reference angle to move us from quadrant to quadrant. So if we're trying to get from quadrant 1 to quadrant 2, since this is 180 degrees, we would do 180 minus the reference angle to get into quadrant 2. We would do 180 plus the reference angle to get into quadrant 3, and we do 360 minus the reference angle. Sorry, I think that went off the video. Let's move that down here. 360 degrees minus the reference angle to get into quadrant 4. Quadrant 1 is already where the reference angle resides. So it's very important that you understand how to find reference angles and how to use them. And you're always either adding or subtracting from 180, depending on whether you're trying to get bigger or smaller, or you're subtracting from 360. And that's how you get into the other quadrants. Now the question is, why didn't our calculator just give us both values? And there's a reason for that, but I'm going to postpone explaining that until we get to section 8.5. When we get to section 8.5, we'll go into the details of why the calculator gives us the answers that it gives us. So you just have to be a little bit more patient for that one. Okay, so that's our first example. Let's take a look at our second example today. Our second example says tangent squared theta plus tangent theta minus 6 is equal to 0. So this is going to factor into tangent of theta plus 3 and tangent of theta minus 2. Just like t squared plus t minus 6 would be t plus 3t minus 2. It's the same idea. We're just using tangent of theta instead of t. Now, we want to solve this on the interval 0 to 2 pi. Now, notice, this time it's a closed interval, square brackets. What does that mean? On the open interval, if we got an answer of 0 or 2 pi, we could not use those as our final answer. They were not allowed by the instructions. Now we can actually use 0 and 2 pi should they happen to be our solutions. Doesn't mean they will be, but now if they are, we don't have to throw them out. We can keep them. Okay, we're now going to set each factor equal to 0 and solve. That's going to give us tangent of theta equals negative 3, which gives us theta equals inverse tangent negative 3. Here we get tangent of theta equals 2. So theta equals inverse tangent of 2. Now we have to solve for theta. 2 and 3 are not unit circle values, not by themselves anyway. If there was a square root of 2 involved also, or a square root of 3 involved also, then they might be unit circle values, but not as they stand. So we're going to have to punch these into our calculator. To do this, we need to make sure, first of all, that our calculator is set to radians. So let me get my calculator. And let me set my calculator to radians. There we go. And so I'm going to punch in inverse tangent of negative 3. So second function tangent of parentheses. Don't forget the parentheses there. Negative 3 gives me an answer of negative 1.2 radians. So theta is about equal to negative 1.2 radians. So I'm not going to write radians. There's only one problem here, though, guys, and that problem is that negative 1.2 is not between 0 and 2 pi. 0 is 0. 2 pi is about 6.28, right? 2 times 3.14159. It's about 6.28. Negative 1.2 position-wise is just fine on the circle, but numerically it's not between these two values. So whenever we have an angle, a negative angle that's too small for our unit circle, we're going to find a coterminal angle that gives us the equivalent values for all of our trig functions by adding 2 pi to that. And so I go back to my calculator and I take that value and I would leave the whole thing in there and then do plus 2 pi. And it gives me about 5.0. So theta about equals 5.0 radians. So let's stop and think about where that is. And these are numbers you're going to want to write down. We're used to thinking of this as 0, pi over 2, pi, 3 pi over 2, 2 pi. We now want to think in terms of decimals. 0 is just 0. Pi is about 3.14. Pi over 2 is half of 3.14, which is 1.57. And 3 pi over 2 is 3 of these, which is about 4.71. 2 pi is 2 times 3.14, which is about 6.28. So this is our radians in terms of decimals rather than in terms of pi for our circle. So the question is, where is 5.0 radians? 5.0 radians, just like negative 1.2 would be, is going to be down here in quadrant 4. Right? 3.14, 4.71, so somewhere in here is 5.0 radians. Let's make this look a little bit cleaner. Let me do it this way. The question is, where else is tangent going to be negative? Well, remember that tangent is negative wherever sine and cosine have opposite pluses and minuses. So tangent is negative in quadrant 4 with positive cosine and negative sine. It's also going to be negative in quadrant 2 with positive sine, negative cosine. The question is, what is the angle going to be? So what we need to do, guys, is we now need to figure out what our reference angle is. The closest place on the x-axis is going to be going to here. From 5.0 to 6.28 is about 1.28. Now, I made this into 5.0 by using the actual 2 pi. To get a little bit more accurate so that we're a little more consistent, what we could do is we could have made this negative 1.2 and just added 6.28 to that. And that's going to give us 5.08, which is really about 5.1. So to get a little more accuracy, a little more consistency, excuse me, I'm going to make that 5.1. Should have done that really in the first place. It would have been a little bit cleaner. So the question is, how big is this reference angle? Well, this reference angle is going to be 6.28 minus 5.1, which is going to be 1.18 or about 1.2. But this difference here is going to be our reference angle. So if I go back to my calculator for just a moment, remember this was negative 1.249. Now, if we use more decimal places, we get a little more accuracy from this stuff. So I apologize. Rather than using the nearest tenth, let's make this a little bit cleaner for you guys. Since we're using 2 decimal places on all of these, we're going to use 2 decimal places on these. So I should have done that in the first place. So let's make this negative 1.25, 2 decimal places. And so this would have been negative 1.25, and then we would have added 6.28 to that, which would give us 5.03. That's better. I like that better. Then all of our numbers are using the same number of decimal places, so we're being more consistent. All right, so let's take a look at how we now apply this thing. Sorry, this shouldn't be 5.03. This is 5.03. So from 6.28, 5.03 is 1.25. Notice it's just the positive version of this because a reference angle is always a quadrant 1, so it's a positive angle. That's our reference angle, which means that this must also be 1.25 radians. So the question is, how do we get to this location? Well, notice that we're closest to 3.14 on the x-axis, and since we're going to be less than 3.14, we're going to do 3.14 minus 1.25. 3.14 minus 1.25. It's going to be 1.89. So again, let me go through how we got that again. First thing we did was we did inverse tangent of -3, which gave us this value. The problem is this did not fit in here. So we had to add 2 pi, 6.28 to it. That gave us this location. We then found our reference angle by figuring out how far away this was to the nearest place on the x-axis. It was 1.25 radians, 6.28 minus 5.03. We then went over here to quadrant 2, and we subtracted from pi, 3.14, that 1.25 reference angle. That's where we got our 1.89. So these are going to be the two solutions to this first chunk of our equation. 1.89 radians, 5.03 radians. So let's do that again now that we got the whole decimal thing squared away, so that you can see a little more cleanly how we do the second part of this. So now we're going to do inverse tangent of 2. So we go to our calculator and we do second function tangent. It's just a single number, so I don't really need to worry about the parentheses. This is 1.11 if we round it 2 decimal places, which is what I'm going to recommend that you do. So here we get theta is about equal to 1.11 radians. If I look at my same numbers, 0, 6.28, 1.57, 3.14, 4.71, my 1.11 is somewhere in here. My reference angle is therefore 1.11. Right, because that already is a quadrant 1 angle, so I don't have to make any adjustments. I can just write it down. The question is, where is tangent going to be positive besides quadrant 1? Tangent is going to be positive in quadrant 3, where x and y are both negative. Negative divided by negative is positive. So I need to go down here. The question is, what will this angle be? Well, now this has to be our reference angle. This is 3.14, but that's not far enough. We have to keep going. So now we're going to add 3.14 plus 1.11, which gives us 4.25. And so these are the two places that will satisfy this part of the equation. And so our final answer altogether is that theta is equal to 1.89, 5.03, 1.11, and 4.25 radians. It's kind of close to going off the edge of the video. Let me just pull that back just to be safe. So again, you get the initial value from your calculator. You use that to find your reference angle. You use the reference angle to find the value in any other quadrant that's appropriate. So that's our second example for today. Let's look at one more example. So example number 3 is going to be 3 tangent squared x minus secant squared x minus 5 equals 0. So now we're getting into ones where we don't have all one trig function. And so as you would imagine, we're going to need to make some substitutions. We really want there, if at all possible, to be just one type of trig function. And so what we're going to do here is I'm going to take my secant squared x and I'm going to change it using our Pythagorean identity into tangent squared x plus 1. If you do not know your identities, you must go home and memorize them. There's no way around it. You cannot survive in trig without knowing the identities. And it was clear from the last test that a lot of you did not go home and study your identities because you were using the wrong identities. You had the right idea concept-wise. You understood what you were supposed to do to simplify things, but you used the wrong identity. You made up your own instead of using one that's actually true. That's causing problems. So you need to know your identities. Secant squared is tangent squared plus 1. Now we distribute the negative and we end up with 2 tangent squared x minus 1 minus 5 equals 0. Bring these guys to the other side and you get 2 tangent squared x equals 6, which gives us tangent squared x equals 3, which gives us tangent x equals plus or minus the square root of 3. Don't forget the plus or minus. Now, we don't need the calculator for this one, because square root of 3 is a unit circle value. We actually saw this on the previous video, but I believe we did it in degrees if I'm not mistaken. And so tangent of x is equal to square root of 3, where y is square root of 3 over 2 and x is 1/2. So to get the positive version, we want to be up here at, we want to solve this for x, we want all x in radians. So for the positive version, we're going to get pi over 3. And then when sine and cosine are both negative, we also get positive tangent. So that's going to be down here at 4 pi over 3. Apologize, guys. The hiccups are setting in. All right. Now, for negative square root of 3, we're going to get those same locations, but in the other two quadrants. So we're going to be up here at 2 pi over 3 and down here at 5 pi over 3. And so what we end up getting all together is we end up getting that x is equal to pi over 3. And because it's all values, it's going to be plus 2 pi k, like we talked about yesterday. 2 pi over 3 plus 2 pi k. 4 pi over 3 plus 2 pi k. 5 pi over 3 plus 2 pi k. And that's our final solution. Now I want to point something out to you that you need to be on the lookout for. I don't require that you write your answers like this, but understand that in the back of the book when you check answers, which you need to be doing, some of you are not, you need to understand that there is a way to combine these two and there's a way to combine these two. And the reason is that pi over 3 and 4 pi over 3 are exactly pi radians apart. They're exactly half a circle. And so that means that instead of having to go all the way around back to here, I can go half a circle, pi radians to here, and then if I add that pi again, I get back to here. And then if I add another pi, I get back to here. And if I add another pi, I get back to here. And I can just bounce back and forth between those two locations just by adding pi. So I can condense those two into pi over 3 plus 1 pi k instead of 2 pi k. Likewise, these two are 180 degrees apart, and so I can take care of both of them by writing 2 pi over 3 plus 1 pi k. And so this is an alternative way to write this answer. You can write it as 2 instead of 4, but with pi k. I do not require that you do it that way. I don't care which way you write it. I'm perfectly happy with both. It shows me you understand what you're doing. But understand that if you write the 4-answer version and in the back of the book they write the 2-answer version, just understand what you're looking at so that you realize, oh, look, I see what they're doing. I've got the right answer. They just wrote it differently. Okay, so that's the last of our examples for today. And you can go ahead, hopefully, and have some time to get started. Try at least a couple of problems tonight. Make sure the material from the video is sinking in. Go back and re-watch anything you need to re-watch, and then we'll continue working on it in class tomorrow.